Yes, hello, dear friends. Now we are solving the 2 marks problem. Okay, let's start without wasting the time. In this question, the question is asked: a glass rod is rubbed with a silk cloth. Glass rod acquires charge of 1.6 into 10 to the power minus 13 coulomb. Find the number of electrons transferred to this silk cloth. Okay. Now it can be solved by using the quantization rule of the charges. What is that? Q is equal to n in plus or minus n into E. Okay, you have to find the number of electron transferred, so that n it is equal to Q divided by E, where E is the charge of the electron. Okay, charge it is given 1.26 into 10 to the power of minus 13 coulomb divided by charge of the electron 1.6 into 10 to the power of minus 19 coulomb. Okay, now 1.6 is we get 1 and 9 19 coulomb. It is the 19 coulomb. No. Okay. Now 19 minus 13, it become 10 to the power of 6. Okay, number of electrons. That's it. That's all. Hope that you have understood. Hello, dear friends. In this question, asked the test charge of magnitude 1.5 into 10 to the power of 99 coulomb is placed at a point where the electric field is 5.4 into 10 to the power of 4 Newton per coulomb. Find the force experienced by the test charge. Okay, how much the test charge will experience the force? For this, we can use this formula. F it is equal to Q into E, isn't it? Okay, now F it is equal to, what is the charge? Charge is 1.5 into 10 to the power of minus 19 coulomb. 19 coulomb. And this place where the electric field is into 5.4 into 10 to the power of 4 Newton per coulomb. Now multiply both of these, it becomes 8.10 into 10 to the power minus 5 Newton force. Simple. That's all. Hello. In this question, it is asked a charge of 1 microcoulomb is distributed on a circular ring of radius 5 centimeter. Find the linear charge density. Okay. The linear charge density. Linear charge density is expressed by lambda. Lambda is equal to Q divided by L. Okay. Here the circular ring is there. Circular ring. Now the length of the circular ring will be the circumference of the circle. Okay. Circumference equation is 2 pi r. 2 pi r. Now finding the circumference 2 pi r. Now it will becomes 2 into pi into what is the 5 into 10 to the power minus 2 meter. Multiplying this, you will get 5 to the 10 into 3.14. It is the pi value into 10 to the power minus 2. Okay, 31.4 into 10 to the power minus 2 is the circumference of the circle. Circumference of the circle, and the circumference of the circle is length of the rod. Okay, meter. Length of the rod. This much it is. Now coming back to the formula, lambda it is equal to Q divided by L, so that what is the charge? 1 microcoulomb, 1 into 10 to the power minus 6 microcoulomb. Okay. Now 1 divided by length of this 31.4 into 10 to the power minus 2 minus 6 get cancelled. minus 2 minus 6 or 6 minus 2 is 4 into 10 to the power minus 4. It remains 1 divided by 31. 1 divided by 31, how much it will be? 0 0.03. 0.0318. Okay, it will be this much. Lambda, so that unit becomes coulomb per meter. That's all. Hope that you understand. In this question, what is asked? In this question, it is asked, a charge of 1 microcoulomb distributed over the metallic sphere. Okay, metallic sphere is there. Okay, whose radius is 5 centimeter. Now, find the surface charge density. Now, the surface charge density is expressed by sigma. Sigma, and sigma it is equal to Q divided by A, charge upon area. Charge is 1 microcoulomb. For micro, we have to write 10 to the power minus 6 divided by area. Area of the sphere is 4 pi r square. Surface area of the sphere. Okay, 4 pi r square. Okay, you have to multiply 4 into 3.14 into 5 into 10 to the power minus 2 whole square, because r square is there. 4 into 3.14 into 25 into 10 to the power minus 2. Minus 2 become minus 4 because the square is there. Now it will become 25 4s of 100 into 3.14 into 10 to the power minus 4. So that it will become 314 into 10 to the power minus 4. Area becomes this much, meter square. It will be meter square. Okay, coming back to the equation. Now area, put this value 314 into 10 to the power minus 4. Okay, 6 minus 4 becomes 2 and power minus 2. 1 divided by 3.314 becomes 0.0318. 0.0318 into 10 to the power minus 2. Here coulomb per meter square, because the charge upon area is in this formula. Using this formula, it will become this much. Okay, become this much. Hope that you understand. Hello. In this question, the question is asked. What is asked is an electric dipole. With the dipole moment is given. It is equal to 4 into 10 to the power minus 9 coulomb meter. Okay, is making an angle 30 degree. 30 degree angle is making. Okay, next with the direction of electric field of magnitude 5 into 10 to the power 4 Newton per coulomb. Calculate the magnitude of torque acting on the dipole. Okay, for the dipole, torque acting on the dipole is given by the equation tau. It is equal to Pe sin theta, isn't it? Now, so that what is the dipole moment? 4 into 10 to the power minus 9 coulomb meter. Okay, now what is the electric field? Electric field is 5 into 10 to the power 4, and theta sin 30 degree. It is sin 30 degree. What is the sin 30 degree? 4 into 10 to the power minus 9 as it is into 5 into 10 to the power plus 4 as it is, and then sin 30 is 1 by 2. 2 2s are 4, 5 2s are 10, 10 into 10 to the power 4 minus 9 is minus 5. So that torque it is equal to this much Newton meter. Okay, because torque is nothing but the force into displacement, so that it will becomes 10 to the 5 into 10 into 10 to the power minus 5 Newton meter. That's all. Hello. In this question, it is asked a charge of 1 nanocoulomb is placed in air. Okay, charge is placed in the air. Estimate the electric field at a distance of 2 centimeters from the charge. Okay, one of the charge is kept here, 1 nanocoulomb. Okay, at distance of 2 centimeter, the electric field is asked. E is equal to how much? E equal to how much? Now, the electric field equation is E, it is equal to KQ divided by R square, where R is the distance from the charge to the point. Okay, value of the K is 9 into 10 to the power 9 into charge value is 1 nanocoulomb, 1 into 10 to the power minus 9 divided by R square. R is 2 centimeter, 2 into 10 to the power minus 2. We have converted into meter. Okay, square. Okay, now plus minus 9 plus 9 get cancelled, power 10 power minus 9, 10 power plus 9 get cancelled, which is 9 only. 9 divided by 4 into 10 to the power minus 4. Minus 4 goes upper side and it becomes 10 to the power plus 4. 9 divided by 4 becomes how much? 2.25. 2.25. 4 to the 8 and become 10. And it will become this much only. 9 divided by 4 becomes 2.25. Okay, 2.25 into 10 to the power plus 4. Okay, now electric field is this much only, Newton per coulomb. Okay, hope that in this question research the 2-point charges 2 nanocoulomb minus 4 nanocoulomb are located at 0.2 meter apart in vacuum. Find the electrostatic force between them. The electrostatic force between the two charges is given by the equation F is equal to K Q1 Q2 divided by R square, where K is the force constant whose value is 9 into 10 to the power 9. Okay, now the charges are given there. Okay, K is 9 into 10 to the power 9 into Q1 is 2 nanocoulomb, 2 into 10 to the power minus 9 into minus 4 nanocoulomb. Don't take the minus sign. Okay, only we will use the negative sign for the direction only. Okay, because it is a vector quantity. Okay, 4 into 10 to the power minus 9 whole divided by 0.02, or shift the point and it will become 2 into 10 to the power minus 2 meter. Okay, it is square. Okay, now solve it. 10 power plus 9, 10 power minus 9 get cancelled. 9 into 2 into 4 into 10 to the power minus 9 remains. Okay, divided by 4 into 10 to the power minus 4. It will become just like 4 get cancelled. 9 to the 18 into 10 to the power 10 power minus 4, and this goes upper side and become positive, so that 10 power 4, 9 minus 4 is 5. Okay, 10 power plus 5 or minus 5, minus 5, sorry, 10 power minus 5 will become 10 power minus 5. 9 minus 4 is 10 power. Okay, this much force will attract, and this much force will be there, attractive force. Okay, and it will be attractive force because there are two opposite charges. Okay, here is the 2 nanocoulomb charge plus 2 nanocoulomb charge, and here is the minus 4 nanocoulomb charge, and one of the positive charge and one of the negative charge. Then force will be attractive type. Okay, they will attract. Like charge repel each other and opposite charge will attract each other, so that it will be attractive force. Attractive force. Okay, that's all. Hello. In this question it is asked a 2 microcoulomb point charge placed at a point P in a uniform electric field and experience a force of 1.6 into 10 to the power minus 6 Newton. Find the magnitude of electric field. Okay, here one of the electric field is there. Okay, this is the electric field. Its value is don't know. Okay, here one of the charge of 2 microcoulomb is kept. it will experience the force. It will experience force because it is the positive charge and electric field is there. It will experience the force along the direction of electric field, okay, in this direction only. Force is given by F, it is equal to how much? 1.6 into 10 to the power minus 6 Newton. Okay, now we know that F is equal to Q into E, the electrostatic force will be this much. Okay, now we have to find the electric field. E is equal to F divided by Q. So that what is F? 1.6 into 10 to the power minus 6. And what is the charge? Charge is 2 microcoulomb, 2 into 10 to the power minus 6. Okay, shift this one of the decimal point, one digit. Okay, now 1.6 become 16 into 10 to the power minus 7 divided by 2 into 10 to the power minus 6, and it will become 2 ones are 2 8s are 16. Okay, 8 into 10 to the power and 7 minus 6, it will become minus 1, and it will become 0.8 Newton per coulomb. It is the electric field, Newton per coulomb. Okay, that's all. Hope that you understand. Thank you for watching this video. In next section, we will do the next problems or next question.